This is MATD 1544. We're busy with limits, and we're going to look at the one-sided limits topic. So we already did discuss now more or less what we mean by limits and how it came to pass. And we started with average gradient, and then the gradient of the tangent, and the whole problem of that we must not divide by 0, and Newton that came up with a plan, changed the notation, and made a brilliant discovery for us to be able to work out tangents, the gradient of the tangent, and so on. But in this short recording, we're just going to look at the left-sided and the right-sided limit, or right-handed, or right limit, or left limit. Now, first of all, the notation, just look that you see it properly. So when there's a little positive there, it means that we are looking at the limit by approaching the number from the right-hand side, from the positive side. It doesn't mean A is positive. Just be careful there. It's also not an exponent or something or anything like that. It just means that we are approaching the number from the positive side. And then if we have a negative at the top there, in the place that we put the exponent, then that means that we are approaching the number A from the negative side. All right, so calling it the left-handed limit or the left limit or so on. So if we can just look at the example here, if we have this function, the step function and so on, and we look now at 0 here, there's a problem at 0. We can clearly see there's a problem at 0. The graph was over here and now it's suddenly over there. Something happened at 0. Now, when we come towards 0, in other words, approaching 0 like the arrow is showing, from the negative side, then we are approaching 0, and we see we're approaching 0 on the x-axis. That's what I mean. So we're approaching from -3. In other words, we're approaching x equal to 0 from the negative side, and then we see y will also then be 0. So the left limit here will be 0. If we're approaching 0, again on the x-axis, we're approaching 0 from the right-hand side, from the positive side. So starting, say, at 3, and we're approaching 0, must be on the graph. So now we're approaching 0, x equal to 0 from the positive side, and we can clearly see that y is now approaching 1, meaning that the right-hand side limit will be 1. Now, when the left-hand side limit and the right-hand side limit is different, we say that the limit at 0 does not exist. It's undefined. So the only time that the limit can exist is if the left side limit and the right side limit is exactly the same. Okay, this is then very important. Okay, so we only have a limit that exists if the left limit and the right limit is equal to one another, and of course, both exist and is equal to one another, giving a value L, and then the limit will be that value L. Okay, so let us look here, discuss a little bit what is going on here. If we look at this function that is graphed here. First of all, let's look at -4. Okay, we clearly see that f of -4 is undefined. Be careful not to say it's 2, because there's a hole there, a hole in the graph, meaning it is undefined, it doesn't exist there. So, if we come from the negative side towards -4, so on the graph we're approaching -4, we can clearly see that our y is approaching 2, meaning the left limit will be 2. If we approach -4 from the right side on the graph, we will see that our y will also approach 2, meaning the right side limit will be 2. So now we can say that the limit at negative 4 is 2. So the limit exists and it will be 2. Now, when that happens, in other words, there is no function value, but the limit exists, we say that there is a removable discontinuity. A removable discontinuity. Okay, let us look at x equal to 1. What is happening here at 1? There's definitely something happening there. Well, first of all, f of 1 is 4, because that is where the dot is. So we've got a dot on the line, or on the curve, indicating that value exists there. So f of 1 is 4. Here is a hole, meaning that f of 1 cannot be minus 2. It doesn't exist there. Okay, so that's the first thing that we must just make 100% sure of. So at negative 4, we had no value for the function. Here we do have a value of the function. F of 1 is 4. Now, what about the limits? Well, if I approach 1 from the left-hand side, from the negative side, my y definitely approaching 4. My y is approaching 4, meaning the left limit will be 4. If I approach 1 from the right-hand side, positive side, my y definitely approaches negative 2, meaning the right-hand side limit will be negative 2. So this limit does not exist because the left limit is not equal to the right limit. And when this happens, we call this a jump discontinuity, a jump discontinuity. Okay, so there's a jump discontinuity at x is equal to 1. All right, the third situation that we can find is that at 6, the function value exists because f of 6 gives me 2, so that's the value of the function. And then if we do the left limit, approaching from the left-hand side, we're definitely approaching 5. Approaching from the right-hand side, we're also approaching 5. So we can say the left limit is 5, the right limit is 5, therefore the limit exists and it is 5. But here the function value is 2. So not like in the previous case where we do not have a value for the function. So if we can just complete the activity here. So f of negative 4 is then undefined. We don't have any value for f of negative 4. So that will be undefined. Okay. The next question they ask is, what is the left limit? Because there's the little negative. If I approach negative 4, we said that that is going to be 2. Okay, so that's going to be 2. What is the right limit? If we approach negative 4 from the right-hand side, we also said it's going to be 2. So that also gives us 2. So because this is exactly the same, both exist, and is exactly the same, the limit then will be 2. Right. What is f? And then we said this is now a removable discontinuity. All right. So f of 1 we said is 4. It's going to be 4. Okay, what was the left limit? If we approach 1 from the negative side, it was 4. So the left limit was 4 there. Same as the value of the function. Okay, what is the right limit there? The right limit is approaching negative 2. So that is negative 2. What is the limit there? It doesn't exist because the values aren't the same. It's not the same. Here they were the same and the limit exists. Here the left and the right limit is different. It doesn't exist, so the limit is undefined. We cannot define a limit here. Okay, so the limit there is undefined, and then we call it a removable, a jump discontinuity, if that happens. A jump discontinuity. Okay, it's a jump discontinuity. F of 6 was 2. All right, f of 6 is 2. So please, limits is such an important topic, and the basics to understand it is so important for our future. Sorry, I just had a look here. I think I must just, in my hurry, I did not do this properly. Discontinuity. Sorry, I'm not so good in my languages. Maths is a bit better. So f of 6 is 2, we said. Please, I'm just emphasizing again the importance of understanding the concept of limits. So f of 6 is 2 because that is where the dot is. The left limit there is 5. The right limit there is 5. And therefore the limit there is 5. But we have a value of the function there, which is 2. Okay, so here, if the limits are the same and the limit exists, we don't have any function value there, we say we have a removable discontinuity. A removable discontinuity. Remember, because we don't have any value of the function here. Discontinuity. Nuity. All right. Okay, I hope this makes sense. I will just advise you to also look at the other notes I've put for you. I've put for you also these notes of the Unity Maths notes from Cape Town University, or around about there in Cape Town. And all stuff about limits are also discussed. And there's also the concept of the left limits and the right limits. We have done this in class thoroughly, but for those of you that is online, please go over here. We also have left limits and right limits, so go look at, try it yourself, like question 14, there's others also, and here see if you, and then at the back, see if you can do it, and then at the back or underneath, you will have the solutions here. You can just go to the solutions and mark yourselves. But please make sure that you do understand how to work with left limits, right limits, when they exist, when they not exist, and the discontinuities that can happen.